Hi, I am Miss Fitzgerald Williams,
And Miss Angelo.
and we're going to be talking to you about 7-3 logarithm functions as inverses. Definition. The definition of a logarithm with base b, which is kind of like this in this red, log base b of y is equal to x if and only if, we didn't typo that, if and only if b to the x is equal to y. They're inverses of each other, just like addition is the inverse of,
Subtraction.
and multiplication is the inverse of.
Division.
That's right. So this is only great for when b is greater than 0 and b does not equal 1. So there are some common logs, and on a test we will only write log x, and we expect you to know that this is the common log, so the base is automatically 10. So if you don't see a specific base here, the base is 10.
And for the natural log, the base is going to be e. So for if you see something that looks like this with an ln, that's the natural log, and it's just log base e.
True fact. When have you seen ln? Yesterday, when you're trying to get to the e on your calculators, or the previous lesson. Okay, so they are inverses of each other, and exponentials and logarithms, that's what I just read. Yep, my bad. They're inverses of each other, which means that they are reflections across the line y equals x. So here's a great thing. Their domains and ranges swap. So the key points and stuff that you had yesterday, they're just going to flip them around. But in terms of inverses, you have y equals log base 8 of x, and then the inverse of that is just y equals 8 to the x. So things you want to highlight. The base 8, log base 8, is y equals base 8. Base. Are we all about that base, Miss Angelo?
We are all about that base.
No trouble. And so instead of this being an exponent, this is just an x. We didn't rehearse that. It was just off the top of the head. So log ln, natural log of x, is the inverse of e to the x. So
Because what do we know about the natural log? It's log base e. So the base is going to be e.
good. Hey, let's try this with the common log. So see there, she didn't write that, but it's log base 10. So what would the inverse be, Miss Angelo?
It would be y is equal to 10 to the x.
Perfect. All right, let's keep it going. Find the inverse of each thing, of each equation. So what do we do first? Well, first we swap the x and the y. Okay, so I switched the x and the y, and I have now x equals log base 2 over 5 y. And I know that these are inverses, but here's what you're really doing, and we'll talk more about the y of this next chapter or after we get out of the graphing. But we're exponentiating. Yeah, I know you like that word. So that means this is now the base, this is now the base, and what happens on the right side is that these cancel out, so all I have is y is equal to 2/5 to the x power. And that's the inverse. Okay, you want to try the next one, Miss Angelo? You want me to talk?
Sure.
Oh, great. Miss Angelo's going to write for us, and so I guess she's going to swap the x and the y first. Okay, so Miss Angelo, we said that we have to exponentiate to both sides, but I don't see a base on ln. What do I do?
Let me rewrite this so that we can see it easier. If I rewrite this as log base e of y plus 10, then now we know that the base is e. So when we exponentiate,
P.S. I don't know if that's a real word, but I think
it is, it
Okay.
is, it is, definitely is. So this is going to cancel out, and then all I'm left with is whatever my exponent is on the right side. So I have y plus 10 on the right, and then on the left I have e to the x.
Love it. Y is not alone, and we need it to be. What's next, Miss Angelo?
I think we should move that 10 to the other side. So we're going to have e to the x minus 10, and then that's going to be equal to our y. And then this is going to be our inverse.
I have several students that are so going to appreciate that you boxed that because it's your final answer. Can I borrow that pen and box my answer as well, just because You know, my VIP list is going to appreciate it. Okay, so now let's talk about the graphs. There is an issue with this graph, Miss Angelo, and the issue is that the asymptote did not show up for us. So I'm gonna go ahead and draw it in, and we would love for you to draw yours in as well. Okay, it's not dashed, but it kind of could have been, and it should have been, but that's cool too. So here's our base function. The graphs of base function. So the first one is log base b of x. There's not going to be an a in front or anything else. This is going to be your base function, nothing in front of here. Why? Because you haven't learned that yet, and we'll talk about it next chapter. What about our general function?
So our general function is going to be y is equal to log base b of x minus h plus k. And the k is on the outside of that parenthesis. So don't include it because the h and the k are going to be what we're shifting.
Copy that. I like that the h is still the same shift as it was before, and the k is still your vertical shift, so that's great as well. Here's what we know. Let's review just for 1 minute. Is that okay, Miss Angelo?
Yeah.
Thank you.
I don't know what this vertical line means.
Right, I know it. I'm going to talk about that.
Let's think about that.
Let's do that. Here's what I know. I know because you taught me that we had y equals a. That's not working. Y equals. My writing's going away, Miss Angelo. Let's pause for some technical difficulties. Pause. Okay, look that. Look at we fixed it. That was amazing. It's like time stopped, or we pressed pause. So y equals a b to the x. That's what I know from our previous lesson. Yes.
Yes.
Yes, because you taught me that. And from this, I know that my key points were 0, 1, and 1, A, B.
So what did we say about the log in relation to my exponent function?
We said that they were inverses of each other, which means that I should be able to just switch them around. But first, let's talk about this. We had 0, 1, and then you had 1, let's say, AB. We also, for the previous lesson, Miss Angela, we had an asymptote, which for this one would be
Y equals 0.
y equals 0. So that would have been this line right here. And my graph would have gone something like that. That's what I know. But I also remember from inverses that if there's a reflection around the line y equals x, so this mirrors this, which looks like we did that pretty well. So now, though, because you said everything was switched because they're inverses of each other, it looks like instead of having a horizontal asymptote, I have a vertical asymptote. So instead of it being x equals, it's going to be y equals something. But I'm getting ahead of myself. Can we talk about key points, Miss Angelo?
Hold on. Wait. What?
Key points meaning instead of my key point being 0, 1.
So now our key point is going to be 1, 0.
1, 0, got it. And instead of it being 1AB,
It should be
AB1, but we don't have an A. A is always going to be 1, which is nice. So my other key point is just always going to be B1. Always?
always.
Always for this book. I know you're thinking ahead. You're like, not in calculus, but that's fine too. So, hey, here's what we loved about when we had this situation. We loved that the domain was all real numbers, but the domain and range are switched. So instead,
Our range is all real numbers.
all real numbers. That's just some symbolism, and it's okay for us to use. Yes?
Yes, it is.
Okay, all real numbers. And then we have our general form here instead. So my domain will be what for the new function. Not with x, not with y's, but instead it has to deal with x.
So x is going to be greater than, not my k, but this time it's going to be my h, because that is my horizontal shift.
Good deal. And your asymptote is going to be x is equal to?
H.
Perfect. Here's what we like about this. We like that we don't have to think so much, is it greater than or is it going to be less than? It's always going to be greater than h. Love that. Yes? Say yes.
Yes.
Perfect. We're going to start graphing now, and we'll see how this goes. I think it'll go well. Okay. Hi, guys. I'm sorry. We just cut off. Graph Write the domain. So here's the thing. In your book, the directions might be a little bit different. But me and Miss Angela, want you to do this for every single problem that you graph because it's going to be like this on your quiz. So base function, shifts, everything we want you to identify because that's what we're going to expect you to do when you take your quest. Okay, Miss Angelo, what is my base function?
Y is equal to log base 2 of x.
Bummer. Log base 2 of x. That's an L. This is my y. Sorry about that. So what would your key points be?
Let's see. If I plug in 1, it would be 0. And this one. Wait, no, it's b. So what's my b?
What is your b?
2. So it's going to be 2, 1.
2, 1. So here's the thing. I like it. It's always going to go. This is wrong, Miss Angelo. Is it wrong?
If we plug in
It's
2,
1, 0.
1. Oh, yes, it is.
Psych. We got you. 1, 0, and B1. See, that's why it's good to have pencil, so we could erase 1, 0, and 2, 1. Now here's the thing. This is always going to be your key point for logarithms. Always. The other one's always going to be B1. So there's not too much thinking we have to do. What about shifts?
For shifts, I have no h and I have no k. So I'm going to say there's no shift.
No shifts. Okay, and your domain?
X is going to be greater than 0.
And your range?
All real numbers.
Good. What about your asymptote?
X is going to be equal to 0.
Love it. Okay, so x equals 0 is my vertical line. And then we'll plot those points, which is 1, 0, and 2, 1. And then we will connect them. All of them should look like this. So when you're drawing, it should approach the x-axis. Every single graph will have that same sort of a shape. So make sure that you get accustomed to that. Okay, on to the next. All right, here we go. This time we do have some shifts. So what's my base function, Miss Angelo?
It's everything up until that x. So y is equal to log base 2 of x.
Love it. My key points?
1, 0, and 2, 1.
1, 0 is always. B1 is the second one. Looks familiar, no?
Yeah, it looks just like our old function, the one that we just did.
Okay, what's my shift? What are my shifts?
Oh, so here we have an h is equal to negative 1, so it's going to be to the left 1 unit. And then my k is negative 3, so down 3.
Okay, and your domain?
X is going to be greater than my h, so negative 1.
Good. And your range?
All real numbers.
And your asymptote?
X is equal to negative 1.
Good deal. Let's plot all of this. Hey, Miss Angela, look what we did here. I plotted the base points, so that was 1, 0, and then 2, 1, and then here's my basic shape, and then I also drew my asymptote. But can you talk me through the shift, please?
So now we have to shift every one of our key points to the left 1 unit and then down 3. So to the left 1 unit, down 3.
Down 3, got it. And this one to the left,
Left 1, down 3.
3, got it. And so now my asymptote is over here, so I'm just going to follow that same form. There we go. Hey, do us a favor, please. Try the next one on your own. Yep, I probably would not change the scale. You don't have to for the next one, but go ahead. Try number 6 on your own and then check with us. So that means we want them to press that wonderful
Pause.
Thanks. All right. Check your work with our work. Hopefully you did press pause. If not, you're probably going to press pause right now and at least copy down everything that we just wrote. Whack. But our base function, log to the 1/2 of x, key points 1, 0, and 1/2 1. Our shift was up to. Why? Because it's not x plus 2 in parentheses. So that means that's not my h. Nope, it's your k. So it's up to, not in parentheses, so it's your k. Your domain, x is greater than 0 because the h was 0. And your range is all real numbers. X equals 0 is your asymptote. So my base function is in red. Our base function is red. And then my shifted up to function is here. One thing we did here, we forgot to do it in the previous ones, is labeling key points on your axes. So make sure you did that. And check in with us if you have questions. Thank you.
Thank you.